Hello, ladies and gentlemen. For this part of the video, we'll be solving the second part of these questions here. Usually they will be hence solve, which is actually related to our previous identity question as we have proven here, okay? In the first trigonometric video that we've done, we've been doing all the proving, right? So now we'll be trying to solve by using the methods that we've proven here. Okay, so let's look into this first part of the question. Now, earlier in the first part, we already showed that this equation is actually equals to sine theta. So now when we compare this one that here, when they ask us to hence solve, what we have is actually the same thing. Secant theta becomes secant 3 theta, cot theta becomes cot 3 theta, tangent theta becomes tangent 3 theta. So if we were to change this using this identity here, okay, first thing I need to clarify that we obviously can't solve the equation if we were to use these things here that's already been given to us. We need to change it into what we proved earlier. And this will therefore equals to sine 3 theta, okay? Because over here is theta, theta, theta. Here is 3 theta, 3 theta, 3 theta. So this is going to equals to sine 3 theta. And now this is equals to negative sine 3 over 2 for the ranges between negative pi over 2 and pi over 2. So you know that later when we invert the sign, we're going to need to minus it by 2 pi, okay? And of course, this is in radian mode. So now, let's just find 3 theta first. 3 theta is equals to the inverse of negative pi over 3 over, sorry, negative sine 3 over 2, right? What you would do is actually you would inverse sine of sine 3 over 2 and know that these two answers are supposed to be in the negative quadrant. So this is A, S, T, C, right? Okay, the answers here are going to be in the T quadrant and the C quadrant shown here. So let's find for this value here first. Invert sine of sine 3 over 2, you would have gotten a value of 1.04719, okay? Let's just write down some extra values just in case. So since it is the negative quadrant, we need to use 2 pi, we need to first use pi plus this answer here, 1.04719, and this will be 4.18879, okay? And the next one will be 2 pi minus this answer here. So 2 pi minus this answer, okay? 2 pi minus this answer, 5.235995, okay? Oh, sorry. This is 2 pi minus 1.04719 is going to equal to 5.235995, okay? After getting these values in the calculator, we need to minus these values with 2 pi, okay? Because y is in the negative quadrant as well, right? Negative range, right? So these values minus 2 pi. First, I'll do it for this because this is the value in my calculator right now. 2 pi, I would have gotten negative 5.235995 minus 2 pi, I would have gotten negative 1.04719, okay? And then this value minus 2 pi, 4.18879 minus 2 pi, then this will actually give us negative 2.09439. Okay, then from here, these four values that we have is actually equals to 3 theta. This is equals to 3 theta. This is equals to 3 theta. This is equals to 3 theta, and also this is equals to 3 theta. To find the value for theta, is actually just this value here divided by 3. So what we'll do is type it everything into the calculator. 9 divided by 3. This is 1.390, which is actually round up to 1.40. Then this one here, 5.235995 divided by 3, you would have gotten 1.75. This is for theta. Do the same for this, negative 2.09439 divided by 3. This theta value is equal to 0.698. And lastly, for this, negative 1.04719 divided by 3, theta is equals to 0.349. Now, to check if all four of these will fall in this range, what we want to do is change these two values into a decimal. This is negative 1.57 and this will be positive 1.57. As you can see, these three answers here, this, and this, fall in the range of negative 1.57 and 1.57. This does not. So the final answer of theta is actually equals to, starting from the lowest value, negative 0.698, then negative 0.349, and lastly, 1.40. These will be the three answers for your answer here. Okay, ignoring 1.75 because it's out of range. All right. So looking at the next question, again, we need to use, first we showed that this equation equals to 2 sine theta, 2 secant theta, then hence solve the equation of this equals to 4, which is basically just everything on top the same except for 3 theta here. Then this will just simply change to 2 secant 3 theta from the value up here equals to 4. Okay, from here, using some algebra and some identities, secant 3 theta is equals to 4 over 2, which is 2. Secant 3 theta is actually 1 over cos 3 theta, which equals to 2. Then bring the cos up. Cos 3 theta will actually equals to, swap places, right? So it's 1 over 2. Okay, and from here, now, if it's just a cosine theta like this, right, it's easy to imagine. Cosine theta means the period is 360 divided by 2, right? So in a range of, let's say, this is what normal cos theta will look like, but cos 3 theta would actually end up like this. Okay, for the values up until 360 degrees. But our range is only until 180, which means the halfway mark, everything beyond this point here doesn't matter. And since that it is equals to 1 over 2, this is our 1 and this is our negative 1. So 1 over 2 will be somewhere here. From the graph right now that we've sketched, we can see that theta actually has 3 values. So how do we get these 3 values? What we have to do is first inverse this cos. 3 theta equals to inverse cos of 1 over 2. Then inverse cos, change your answer into degrees first, because that's what your question is like. Inverse cos of 1 over 2, you are supposed to get 3 theta either equals to 60 degrees, because using your ASTC, where this is a positive value, A, S, T, and C, okay, 60 degrees, or 360 minus 60 degrees, 300 degrees, like so. Okay, and if we had the next one, it would have been 420 degrees. But I don't know this yet if I did not plot the graph. Let's just say I find these two answers here first. Theta is actually equal to 60 divided by 3, 20 degrees. Okay, then the second one would be 300 divided by 3, 100 degrees. And as you can see here, this will be 20 degrees. This will be 100 degrees. Then how do we find the third one here? To find the third one here, what we need to do is we need to go one more round. First 60, then 300, Then the third round, we have to come back here, okay, which is actually 420 degrees. This will be theta divided by 3. 420 divided by 3, you would have gotten 140 degrees. Then this is at 140 degrees. As you can see here, this is where your 180 degrees mark is, right? So 140 degrees would make sense. All right. And then for your last question here, it is known that this equation up here is equals to 2 cot x secant x. So this is exactly that. You don't even need to change anything. Just rewrite it. 2 cot x cosecant x is equals to 3 secant x, range from 0 to 360 degrees. Then what we want to do is, using identities, change this. This is 2 times 1 over tangent x times it by 1 over sine x. Then it's equals to 3 over cos x. What we can do here right now is we can shift the sine up and then shift the tangent up. So 2 is equals to 3 sine x cos x times by tangent x. And from here, we will be able to see that this changes into tangent x. 2 equals to 3 tangent x times by tangent x. Or in other words, 3 tangent x square, like this. Okay, is equals to 2. So 3, I'm going to move over to the left-hand side. Sorry. Then 3, I'm going to move over to the left-hand side. And we will have tangent x square is equals to 2 over 3. Bring the square over. Tangent x will therefore equals to the square root of 2 over 3. When you bring a square and it turns into a square root, you must remember that they have either the positive values or the negative values. So in this case here, we will most likely end up with 4 answers. Okay, now inverse this value here. Let's do it with the positive ones first. Positive 2 over 3 inverse tangent to find x. Okay, then x will equals to inverse tangent of the square root of 2 over 3. This is first equals to 39.2 degrees. And since it is a positive tangent, ASTC, the second value for positive x is going to be equals to 180 plus this, 180 plus 39.2, you would have 209.2. Okay, then using this same value here, find for the negative values. The one in the negative value is going to be 180 degrees minus 39.2. So 180 minus 39.2, you would have gotten for when, okay, let me just clarify this. This is when x is equals to negative tangent, negative cert 2 over 3, okay? Like that, okay? So that's why we will have to find for this quadrant here, 180 minus 39.2, which is going to equals to 140.8. And also for this quadrant here, because it is a negative, then you use 360 minus 39.2, which is going to give you the 320.8. And this will be the 4 answers for x in this question here. All right. Hope this video helped you guys. See you guys in the next one.